right, guys, this is Mrs. Lyons, and I want to just give you a walkthrough of the calculations that you will be doing on with the data you collect from the lab. Okay, so the first thing that you're going to have to do, we know that what our reaction was that we reacted solid aluminum with aqueous copper 2 chloride, and you made products. This is a single replacement reaction. Okay, so based on that, you should know that since this reaction worked, since we observed something in the lab, the aluminum and the copper switched places, which means we ended up with copper, and that was a solid, plus aluminum chloride. And we really didn't see the aluminum chloride because it was dissolved in our water. Okay, so copper was a solid, aluminum chloride was aqueous. All right, so the first thing that you need to do before you start doing calculations tomorrow is you have to write the chemical equation. Okay, and you're going to use the names up here to create formulas, and then you're going to balance it and include states of matter, which I just told you. Okay. Now, when you did the lab, and I'm gonna just make some numbers up. Okay, these won't be the numbers that you used. When you did the lab, you weighed your piece of aluminum. Oops, and that is this mass. So I'm going to say that my piece of aluminum weighed 1.1 grams. Yours may have weighed way less than that, but that's just the number I'm going to use. And then we use the mass of copper chloride 5 hydrate. Okay, so the blue stuff. Okay, we started with the blue solid and we dissolved in water. So I'm going to say that I weighed 0.61 grams of copper chloride. Okay, you were supposed to get as close to 0.5 as you could. All right. I'm going to say that my weigh boat weighed about 0.52 grams. And let's see, I'm going to say that my leftover wire weighed 0.99 grams. Okay, so I can figure out the mass of the aluminum reacted. All right, so I'm going to say that I had 1.1 minus what was left is 0.99. Whoops. 1.1 minus 0.99 is equal to 0.11. So I'm going to say that approximately 0.11 grams of aluminum reacted. Okay, so that is, you're going to take your aluminum wire and you're going to subtract the leftover. All right. Now, when you get to class on Tuesday, what you're going to do is you're going to take the mass of the weigh boat and the copper that you have left that is in your weigh boat. Okay, so you're going to measure that. Okay, what I want to go through with you today is how you will do these calculations. And one of the reasons that I want to go through this with you is because even though we say that we're starting with grams of copper chloride, our substance that we buy from our distributors is CuCl2 dot 5H2O. So we've got to include those 5H2O in our molar mass. Okay, so this is just going to be a gram to gram calculation, just like we've been doing to figure out our theoretical yield in class, except that we're using real numbers. So I'm going to say that I started with 0.61 grams of copper chloride. All right. So the first step that I have to do is I've got to convert those grams to moles. So I know that 1 mole, and I suppose we ought to put the 5H2O in here just to make, So 1 mole of CuCl2.5H2O, and then I need grams. So let's look at this. So I'm just going to write this up here. So copper is 63.55 grams. We have 2 chlorine, so 35.45 twice. And then for 5 water, that means we've got 10 hydrogen, so 10 times 1.01. So that's going to be 10.10. And then we've got 5 oxygen, so 5 times 16. I'm not going to trust myself on that one. Is 80. All right, so I'm going to add all of those up. So 80 plus 10.10 plus 35.45 plus 35.45 plus 63.55 is 224.55 grams. So that's my mass, 224.55 grams of CuCl2.5H2O. All right. All right. Next step. Now the next step requires me to calculate or to balance my chemical equation. All right. So you're going to have to do that. But once you do, you're going to have moles of copper chloride here, and then moles of copper on top. So that's going to come from your coefficients. Okay. And then the final step is to go from moles of copper, so 1 mole of copper, to 63.55 grams of copper. And that's going to give you your grams of copper. Okay. You're going to do a very similar reaction, only this time starting with grams of aluminum and going to grams of copper. All right. So I said I'm starting with 1.1 grams of aluminum. All right. I need to convert to moles of aluminum, so I use the molar mass. So 26.98 grams of aluminum is equal to 1 mole of aluminum. Then I need my mole ratio again, only this time moles of aluminum will go on the bottom, moles of copper will go on the top, and I'll let you fill that in once you get that equation balanced. And then my final step is to go from 1 mole of copper to my molar mass, so 63.55 grams of copper, and that will allow me to calculate the second grams of copper. All right, now, whichever one of these numbers is the smallest is going to be my limiting reactant. Okay, so let's put that. And I should say whichever number is smaller is my theoretical yield. Okay, so I would write that and put a box around it. Okay, now when you come in on Tuesday, you're going to go back. You're going to weigh your weigh boat and your copper. All right, you're going to get a mass. So let's say that when you weigh your weigh boat and your copper, you get 0.60 grams. Okay, to figure out your mass of copper, actual yield of copper. Okay, so what you're going to do is you're going to take the 0.6 minus, so the boat and the copper, minus the weigh boat. So in this case, this is going to tell me I have 0.08 grams of copper formed. All right. And then you weighed this yesterday, the mass of the leftover wire. You're not going to do anything with that number. You've actually recorded it up here, but you're not going to use that. Okay. So the last thing that you're going to do, so you've calculated your theoretical yield. on the back, you are going to determine your percent yield. So that's going to be what you weighed, the actual, over what you calculated, the theoretical, times 100. All right. So you can say, what is the limiting reactant for this reaction? That's going to be the thing with the smallest number. Okay. And then 2 questions. What is the quantitative data that supports this? Okay. And what I mean by quantitative is using your numbers. All right. And then what qualitative data supports this? So your qualitative data is going to be, what did you observe in the lab that told you which substance ran out and which substance was left over? What did you see that told you that? All right. So you're going to do those calculations and turn this in, and then you'll be done with a really good lab for single replacement and limiting reactant. All right. I hope this helps you know what you need to do. And I will see you in class. Where's my row?